Okay, good day. So today we are looking at what nominal and effective rates. So you need to understand the relationship that we have, and I think we've discussed that your nominal is the one with where the compounding the interest quoted and the compounding periods are different. For example, 15% per annum compounded monthly, but the effective rate is actually your actual interest rate that we are used to, like 10% per annum compounded annually, like that. So here we are going to deal with this and understand the relationship between the two. Now, because you'll be asking some in your questions, exam questions, your effective rate, you need to calculate it from given the nominal rate. Now, you're saying, so this is I norm, nominal rate, and I if effective rate. Now, here we are saying P, which is your principal amount. To get accumulated amount, if we are to be given your effective rate, we know that it's just going to be 1 plus I effective, which in this case you put it as what we call 1 over what is it, 1 over 1. Let's say if it's 80%, it's going to be just 8 over 100. But in this case now, when it's given that it's 15% per annum compounded monthly, I think we have seen that in our first lecture in our finance 3, we see that I normal, we could put our percentage here over number of compounding periods per year times also to the power of what? To the power of M. All together. That's what we'll be having there. Okay. Then that's how you actually get to get I effective. Okay. Now let's see what we're supposed to do here. Calculate the effective rate of an investment that offers a nominal rate of 14% per annum compounded, one quarterly and the other one is daily. Okay. So what do we know? We know that M is your, so I effective, 1 plus I effective is equal to 1 plus I normal over M, which is the number of compounding periods, or to the power of what? M, which is number of compounding periods per year. So M is number of compounding periods in a year. For example, 15% per annum, 15% per annum compounded monthly is going to be I normal will be nominal is going to be 15 over 100, which is 0.15. Then M is going to be what? Is going to be equal to what is it? 12. Okay. So let's move on here and see, understand what's happening here. We're going to say for the first one, 1 plus I effective is equal to 1 plus I nominal over M to the power of M. And in this case, for the first one, what do we know here? What is given to us? I effective is in the question. Then I norm is what? I norm is equals to 14%. M is equals to M for the first one. M1, we're going to say M1 is going to be equals to 4 because it's quarterly, it's 4 times in a year. Let me just put it like this that you can see clearly. Then M2 for the second one is going to be 365 because we have got 365 years, 365 days, sorry, 65 days there. Then what else do we need to know there? That's all that we need. So now let's find here for the first one. We're going to say 1 plus I effective is going to be equals to 1 plus bracket I normal 0.14 over what is how many? It's 4 to the power of what? The power of 4. Then here, what do we get there? 1 plus I effective. You can just wrap this. I effective is going to be equals to 1 plus 0.14 over 4 to the power of 4 minus 1. Okay, then what do we get there? Let's punch our calculator. In bracket 1 plus 0.14 over 4 to the power of 4 minus 1, we get 0.14,75. So I effective is going to be equals to 0.1475, which is approximately what? We know that we multiply by 100, then it's going to be 14.75%. That's what we have, I effective. So Then what we have again, let's move on to the next one for daily. You know that I effective is going to be equals to 1 plus I nominal over M, the power of M minus 1, which we're going to say what is our 1 plus I nominal is 0.14. What about N? N is 365. What about M is 65 or to the power of 365 minus 1? What do we get there? We put also in our calculator 1 plus 0.14 over 365 to the power of 365. Sorry, to the power of 365. Then what do we get? We get, okay, 1 minus 1. What do we get? We get 15%. So we're going to get 15 comma I effective is going to be equals to 0.15024 times 100, which is going to get 15.02%. Okay, that's what we get there. That's our answer. Okay, now let's move on to the next question. Here is saying, Jabu invest. Let's put it like this. What you can see. Sorry. Okay, Jabu invest a certain sum of money for 5 years. We don't know this amount of money. He receives interest of 12% per annum compounded monthly for the first 2 years. Okay, now the interest rate changes to 14% per annum compounded semi-annually for the remaining term. So for the first 2 years, it was 12% per annum. Then the remaining term is actually changed to what we call semi-annually. Now we are saying the money grows to 75,000 at the end of 5 years. Calculate the effective interest rates per annum during the first 2 years. Then calculate how much have we invested initially. Now, so we are asked to find effective rate. So I effective is going to be equal to 1 plus I nominal over M to the power of M minus 1. Okay, then what do we get there? We know that we can just write on top here so that you can see. We're saying for the first 2 years, here, what are we talking about here? Our I is equal to what? 12%, 12 over 100, which is 12%. So that's what we have there, I nominal. Then our M is equals to monthly, is going to be equals to 12. That's our M. So we're just going to say, all right, we don't need to stress here. We're going to say is equals to, sorry, I'm repeating here, 1 plus 0.12, which is 12 over 100, over 12 to the power of 12 minus 1. Let's see what we get there. 1 plus 0.12 over 12 to the power of 12 minus 1. What do we get? We get 0.1268%, which will multiply by 100 here. Then we get, I'm not writing this visible, so I just want you to understand here the percentage that what we get here, 12.68%. So I don't want you to write this as a percent, to say 0.1268%. You mustn't write that, please. Okay. So I effective will be 12.68%. So you must know that I effective is always greater than I normal. So I effective is greater than I nominal. Okay. Then what we have here, we have got let's move on. We have what are they asking? 6.1. So 6.1, we are done. Calculate how much have we invested initially. So now we know that this money have accumulated to what? This money have accumulated to 75,000. Okay, we only have I effective for the first one, for the first year. What are we going to do now? We can also change. It's up to us. We can also change this to what? To nominal, to effective, was if we draw a timeline here, what it means here, this information that we're given, always use the timelines that you can understand much better. T is 0, we invested X. So if you don't know the amount, you just put it as X. Then after T2, you invested, what is it, another amount. Sorry, the interest changed. Then up to T5. T5 now, you have got 75,000. That's what we given there. Then here it means that your X growth for 2 years, then it further grow for what? For 3 years. So here we know that it grows for 2 years. In this case, our N is 2. Okay, our I, we now have it is 12,68 over 100. Okay, because now we are having it now. We know we're just going to use this one. We're not going to use the 12 and everything. Then what do we have here? We have got 12,68 over 100. Then what else do we need to put there? I think it's fine. But now, whatever amount that we get here with X is going to act as a principal amount here with a new interest here, which is what? 14. So I here is 0,14 over what is the same annually over 2. Okay, so that's what we have there. Then our N in this case here will be equals to, because for the remaining 3 years now to get to 5, it's going to be 3 times 2, which is going to be 6, because our N is supposed to be 3 times number of compounding periods, which is 2. Then that's what we get there. So now we want to find how can we get this X? This is what we are looking for now. We are looking for X in this case. So we're going to say X accumulated amount for the first 2 years. We use the formula A is equals to P1 plus I to the power of N. So for the first one, A2, we're going to say X, which is the principal amount, in the bracket, 1 plus I. What is our I? Is what? It's our 12,68 over 100 to the power of what? To the power of 2. Okay, what do we get? We get, let's see, 1, let's put bracket here. Let's put bracket 1 plus 12,68 over 100. Okay, to the power of, we square that. What do we get? We get 1,269,67824X. Okay, then now this one becomes our principal now, because we are saying X, because we are multiplying with X here. This becomes our principal. When we put our principal here, we are going to say A for the 5 years, all 5 years, which is 75 in this case now, which is 75,000. So we just, yeah, let me just put it like this: 1,269,67824X in a bracket, 1 plus, we are now using this now for the remaining 3 years, 1 plus 0,14 over 2 in a bracket, the power of 6. Okay, that's what we're getting there. Then we want to see what we get inside here. What we get inside here, we're going to say bracket 1 plus 0,14 over 2 in bracket to the power of 6. What do we get? We get 1,50, this one. So we multiply this amount here with this amount that we have, so that we can get, what is it? We can say 75,000 is equal to, then let's see here, we multiply it by 1,269,67824. What do we get? We get 1,910,544,4672. Okay, X. Okay, then now we are dividing. The X is going to be equals to 75,000 divided by this. So it's going to be 75,000 divided by 1,90544, goes on like that. Okay, then what do we get here? We're going to say 75,000 divided by our answer. What do we get? We get 39,360.89 rands. So this is what was invested initially. This is what was invested, what called initially is 39,368. What was invested initially must be less than what was what is actually the accumulated amount. Okay. Okay, sorry about that. Now let's move on and see. Investments earns interest at a rate of 10% per annum compounded monthly. Calculate the effective rate on the investment. We need to stress here, we know our formula, I effective is equals to 1 plus I nominal over M, the power of M minus 1. What do we get there? So this is for the, I don't know, this one, A1, we'll call it 1 plus I nominal is what? 0.1, which is 10% over M. What is our M? Our M is what? Our M is 12, because 12 times a year, monthly. From the monthly here, we get 12. 12 minus 1. What do we get there? We're going to punch this in the calculator. Let's see what we're going to get here. 1 plus 0.1 over 12 to the power of 12 minus 1. What do we get? We get 0.10471. Goes on like that, but we multiply that by 100. Then we're going to write it as a percentage, 10.47. Then we can put our percentage now. It's 10.47 percentage. Then calculate the nominal rate. Nominal rate, if the effective rate is 18% compounded quarterly. Calculate the nominal rate if the effective rate is 18% compounded quarterly. So here what we are looking for, we are looking for I nominal. So I nominal here is the one in question, but what is our I effective? I effective is 18%, 18 over 100, which is 18%. You can just put it like that. Now then what else do we have there is what else do we have? What else are we looking for there? We are looking for what our M is equal, was quarterly, our M should be equal to 4. That's what we're talking about there. So we know that I effective is 18%. Now we are done there. So now what are we going to do now? We're going to say 0, so I effective is equals to 1 plus, what is it? 1 plus I nominal over M to the power of what? M. Okay. This is the real formula here. It should be 1 plus. So we're going to put our 1 plus here, because here, the reason why I had to put like this, because we are looking for I effective. So I just have to put the 1 there, but the actual formula should be like this. So here we're going to say 1 plus, what is our I effective? Is going to be 0.18, okay, is equal to 1 plus I nominal. We are looking for it. I nominal, we are looking for it, but our M is what? Is 4. So we put the brackets like that. What is our M there? Is 4 again. Then what do we know? What have we learned now? We have learned that if we say 1 plus our I nominal over 4, okay, we'll say is equal to 4 here over what? Into what? Then 1 plus 1,8, 0.18 is 1.18. Okay, it's 1.18. 1 plus 0.18 is just going to be 1.18. 1.18. So we know that we're going to say 4th root of that. So shift will come here. We say 4, what to call 1.18. Then we see what we get there. We get 1.042. Okay. Then 1.042. 1.042 here. 1.042246635. Okay. Now we take the what? We're going to take 1, that side is going to minus what? Minus 1. Then we're going to say minus 1. What do we get? We get 0.042. So it means that our I nominal is going to be equals to over 4. So we're going to multiply by 4 there. Over 4 is going to be equals 0, what? 0, 4, 2, 2, 4, 6, 3, 5 goes on like that. But now we're going to multiply this by 4 both sides to remove the 4 here, then by 4 there. So we're going to say times 4. What do we get? We get 0,168, what's it called? 986. Then goes on like that. Then I time multiply by 100 to make it a percent. I nominal will be equals to 16,90%. Okay. So I think now you understand. Now always with your answers when you're calculating I effective is always greater than I nominal. So you must not forget that. You must not forget that. That's your answer should be less if it is nominal than the effective, which is 18%. So that's what we have here. So we have got 16 what called percent. So 16,90%. That's what we're talking about there. Let's move on to the next question. Rafika would like to invest saved pocket money. The bank offers here a fixed interest rate of 7.5% per annum compounded monthly. What is the effective annual interest rate on a savings? So again, I effective. So we can call that number 2, number 1, number 2, number 3. Then I effective is equals to what? 1 plus I nominal over M in bracket M minus 1. What are we going to do there? We're going to say 1 plus, what is our I nominal? I nominal is 0.075 over what? What is our M monthly? It's going to be 12 to the power of 12 minus 1. What do we get there? 1 plus 0.75 over 12 to the power of what? To the power of 12 minus 1. We get 0.0763%. Not percent, sorry, times 100, so that we can get a percentage. I effective is going to be equals to 7.76%. So always effective is above nominal, which is 7.5%. Okay, so remember that. Now here, let's move on to question 3. Lerato wants to purchase a house that costs 850,000. She requires to pay a 12% deposit, and she will borrow the balance from the bank. Calculate the amount that Lerato must borrow from the bank. So the good thing here, she is required to pay 12% deposit. So we're just going to say on number 3, 12% of what? 12% of what is it? We just subtract the 12% deposit. So we're just going to say, in this case, we're just going to say the amount that she's paying times what? 850,000. I can't find my rubber here. I could have wrapped this, but it's fine. Then it's fine here. Then we're going to say what? 12, which is 0.12 over 100 times 850,000. What do we get? We get 102,000. Okay, so we're going to say borrowed amount. The other borrowed 850,000 minus 102,000, which she paid. So we're going to say 850,000 minus answer, because the reason I'm saying answer was the previous answer that we just got. So it's still in our calculator. Then we get 748,000. So Lerato needs to borrow 748,000 rands. Don't forget to put the unit. She needs to borrow that amount. Okay, so that's how it is. Let's move on to the last question. Last question now, it is include what called time periods, I think changing of percentages. 21,000 is invested with an interest rate of 7.5% per annum for the first 3 years. The interest rate is then increased to 8.5% per annum for the next 4 years. Then calculate the value of the investment at the end of the 7 years. So now what do we have? We draw our timeline. It's question 3. We draw our timeline. Our timeline should give us the T0 and should also give us where the changes start to begin. T3. So T3, because sometimes it's up to T20, so you can't write everything there. T7 here. So now what are we saying here? We are saying we have got what? 21,000 here, and this 21,000 is charged there. The interest is 7.5. Interest is 7.5, which is 0.075%. Then what else do we have? N is equals to 3 years. Then for the next one here, we are looking at 4 years. And these 4 years, we are saying I is equal to what? 8.25. What did I do now? Over 100, which is 0.0825. Okay, then our N is equal to 4. Then can you see what we are doing here? We're going to first find 21,000 after 3 years. How much will it be? Then that will be our principal amount for the next 4 years again. So we're going to say, okay, A3. So we know that A is equals to P 1 plus I to the power of N. That's our formula. So A 3 years, we're going to say, first 3 years, we're going to say P is 21,000. Okay, in bracket 1 plus, what is our I? 0, comma. This one is just going to be, it's not compounding monthly, just per annum. Okay, it's going to be 0.075 to the power of what? What is our N? 3. Then what do we get? We get 21,000 in bracket 1 plus 0, 0. Oh, I think you also see me punching the comma there. The comma there shows that before that is a 0. Okay, so you can just press a comma there. 0.75 in bracket to the power of what? To the power of 3. What do we get there? We get 26,088,23438. Okay, so this one becomes our principal amount now. Okay, then it's gonna say A for the last four years. This is just gonna be A 7 years, because it's gonna be, we are going to use that 0.088,23438. Okay, in bracket, we are saying it's going to increase what? This is our new principal amount now. 1 plus 0.0825. Okay, to the power of what? What is our N now? Our N is 4 now. Okay, then what do we get? What do we get, guys? What do we get? Oh, our answer, which is that times in bracket 1 plus 0.0825. We close that to the power of 4. Then what do we get? We get 35,822.53. Was this rands? Yes, is in rands. Okay, that's the final answer. Or what you can just do, which is quite easy for you, or you can just say you still apply the same thing, but you're just gonna say 21,000 in bracket 1 plus 0.075 to the power 3. This is your principal. Then you open it again. You are starting another thing again for the next 4 years. 1 plus 0.0825 to the power of 4. So you can just punch it like this. It will give you the same answer. Okay, it's just gonna give you the same answer. 21,000 in bracket. We put what? 1 plus 0.075. Okay, in bracket to the power of 3. Then we open another bracket. 1 plus 0.0825. We close that to the power of 4. then you can still get the same answer. Okay, so this is also another way of just cutting it short. If you don't want to write this comma that I wrote here, you can just put it at, once, then you won't have any problem. You won't have any problem. So this is our final answer there. Just mustn't be dirty. Now, this is our final answer. Okay, now let's move on to the last question. It's saying, Miss Modise invests 54,000 in a fixed deposit savings account for 12 years at an interest rate of 80% per annum for the first 5 years. Now, an interest increased to 9% per annum for the next 3 years, and then decreases to 7.5 per annum for the last 4 years. The interest is compounded annually. Okay. Now, calculate how much money Ms. Modise will have in his savings account at the end of the 12-year period. So here, what do we have here? We have a time period. Just going to draw a simple time period here for this number 4 here. We have T0 there. Then after how long? For the first 5 years. So T5. Then for the next 3 years, which is now T8. Then for the last 4 years, which is going to be T12 year. So we find that for the first year, we are saying our I is equals to 12%, which is 8%, sorry, 0.08. Then our I there for this period for 3 years here is what? 0.09. Then for the last 4 years here, it's I is equals to 0.075. But now what we see there, N is equals to 3, then N is equals to 5, then N is equals to what? 4. That's what we have there. Then now what we can just do here, our principal amount here, total amount, we're gonna say A is gonna be equal to P plus 1 plus I, the power of N. Now accumulated amount for the 12 years, what we just do there, remember, you just take this idea that I have put here. So we're saying we're taking out 54,000. Our principal is 54,000. 54,000 in a bracket. What is our 1 plus I? What is our percentage here? 0.08 to the power of what? 5 in a bracket. 1 plus, what is our new percentage there? 0.09 in a bracket to the power of what? 3 in a bracket. You open another bracket again. What's going to be? 1 plus 0.075 to the power of what? The power of 4. Can you see that 5 plus 3 plus 4 is give us 12 years? Okay. So you punch everything in your calculator. You won't face any challenge there. Okay. So we punch there. When you're punching, make sure that you punch it correctly. Then 54,000 in a bracket. 1 plus 0.08 in bracket to the power of what? The power of 5. Then we open another bracket again. 1 plus 0.09 to the power of, we can just cube, okay, plus, it's not plus, sorry, we are multiplying 1 plus 0.075. We close the bracket to the power of 4. Now, understand something here. The reason why we're doing this one acts as a principal. This whole thing acts as a principal for the second phase. Then this whole amount here acts as a principal. That's why we are doing this, because our formula is equals A P 1 plus I to the power of N. Okay. Then you can find the answer here. We find the answer is 137,222.68. Okay, this is in rands. Okay, so I hope you guys understand this this concept, and you won't face challenges in your exams. And make sure that you draw your timeline, and make sure that you divide your timeline, and you won't have much problems. Okay, thank you so much, guys. Until next time.